definite integral of trigonometric functions. So we have our 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. And then the next column we have derivative. So the derivative of sine is equals to cosine. The derivative of cosine is equals to negative sine. The derivative of tangent is equals to secant square, so on and so forth. So what we are trying to focus on is the antiderivative of this trigonometric function. I can tell you that the most popular one are the first 3. So the integral, or you can say the antiderivative of sine of x is equals to negative cosine. The integral or the antiderivative of cosine is equals to sine. I know this may sound confusing. So that you have the derivative and the antiderivative, and they look so similar. So let me tell you this: the integral of sine and cosine is something you have to sit down, write out, and then make sure you memorize them. So you will have to spend maybe 3 to 5 minutes on this. So write it down, look at them, make sure that is fully in your mind. And then for the rest, the tangent, the cosecant, the secant, and the cotangents, the integral, they are less popular compared to the sine and cosine. I would just say the most popular one is the first 3. And then for the cosecant, the secant, and the cotangent, they are not too popular. Alright, so we have the antiderivative. So what we are trying to do next is I would like you to evaluate these 3 definite integrals using the fundamental theorem of calculus. So starting with the first one we have an integral of sine of x. So we have an integral from 0 to pi over 6 sine of x dx. We are looking for the exact answer, so don't even think about your calculator. So what is the integral of sine? The integral of sine is, take a look, negative cosine. So we have a negative cosine x, and then such that x goes from 0 to pi over 6, and then you plug in a pi over 6, you plug in a 0, and then subtract the result. So that is equals to negative cosine, and then you have a pi over 6, and then minus cosine 0. Is this correct? Nope, you are subtracting a negative cosine. Alright, so let's change that. So we are subtracting a negative cosine, so we have negative cosine of 0. So still remember your trigonometric function. So at pi, I should say, do you still remember the unit circle? So at pi over 6, what is the coordinate? So if you don't want to look it up, it's fine. Just focus on my video. So at pi over 6, so that when the angle measurement is pi over 6, theta equals to pi over 6, the point at the unit circle, the x coordinate is root 3 over 2, the y coordinate is 1/2. And then at the 0, the x is 1, y is equals to 0. So since cosine is for x, so that means we will have to take the negative root 3 over 2, and then minus cosine of 0 is 1. So we are going to minus 1. So this is a plus 1. So for the exact answer, I will just keep the whole thing for the exact answer. Alright, so let's move on to the next one. To save myself a little bit of space, I'm going to move this a little bit. So for the next one, let's use a different color for a better contrast and comparison. So the next one, let's do a cosine. So from negative pi over 2 to pi over 3, we have a cosine dx. So the integral of cosine is equals to sine. So we have a sine of x such that x goes from negative pi over 2 to pi over 3. And then we have the fundamental theorem of calculus. So we have sine of pi over 3 and then minus sine of pi over 2. Negative pi over 2. So this is negative pi over 2. So what is the coordinates? Look at your unit circle. You don't have to look it up right now, so I will just write it down for you. So at pi over 3, what is the coordinate? The x coordinate is 1/2, the y coordinate is root 3 over 2. And then at negative pi over 2, so negative pi over 2 is 90 degree counterclockwise, so which is equals to 3 pi over 2. And then at that point, x is equals to 0, y is equals to negative 1. So basically, you are having a what? You are having a 1/2, a root 3 over 2. Let's make that look like a 3. So you are having a root 3 over 2, and then minus a -1, right? So you are minus a -1. Of course, you can change that to a +1, and I will just leave it as it is. When you do your homework online, you will definitely have to use a +1. So let's move on to the last one. The last one is the integral of tangent. So the integral of tangent, let's use pink. So the integral of tangent, so we have an integral tangent x dx, where x goes from -π/4 to past the π/4. As you can see above, the integral of tangent is equals to ln absolute value of secant x. Why is the absolute value optional? The answer is no, because for ln, just recall the graph of ln in your mind. Do you still remember that ln x must be greater than 0? Because when x is equals to 0, there is a vertical asymptote. So that means for ln, we cannot evaluate ln of negative and ln of 0. So, and then such that, so if you don't want to write another line, you can just put the π/4 and then the -π/4 in there. And then this is ln secant π/4 and then minus ln secant -π/4. All right, so at π/4, what is the coordinate? At π/4, this is the easiest. That is √2/2 comma √2/2. And then -π/4, so you are turning 45 degree clockwise, so which is equals to 7π/4. And then at that area, x is in quadrant 4, so therefore x is positive. So we have x equals to √2/2, and then at quadrant 4, y is negative, so √2/2. And then cosine of x is equals to 1/secant, right? So that means the secant, you will have to take 1 divided by the x coordinate. So this is ln absolute value 1 divided by the x coordinate, and then minus ln absolute value 1 divided by the x coordinate. What is that equal to? So they are identical, so as a result, that is equals to 0. Oh, by the way, what is the 0 represents? The 0 represents the area under the curve, where the area under the curve of tangent x, where x goes from -π/4 to π/4. So since this is equals to 0, I am sure that there is a piece below the x-axis and there is a piece above the x-axis, and they have the same area. So since the piece below the x-axis is negative, they just got cancelled. And then how about the one above? How about this one? So this one is the answer represents the area under the curve of cosine x, where x goes from -π/2 to past the π/3. All right, so the fundamental theorem of calculus is right over here. So you are using the antiderivative of the upper limit minus the lower limit. All right, okay, so that is the end of this video. If you like the way I explain integrals, give me a thumbs up and a subscribe, and I will see you all in the next video. Signing out.